last year again. All right, so I decided to do a video on the routing process since I am doing the Network Plus Bootcamp. Want to give something a little extra for the students and put that up there, and for you guys if you're still having issues with how things get from point A to point B. So this lab that I'm going to share right now is what we're going to be working with. So let me share that real quick. You have 3 routers. All right, the IP addresses is IPv4, unfortunately, but it's IPv4. You have 3 routers. The 3 switches are not doing anything. They're just there for the topology. Okay, I don't think this is like move switch. There we go. And then you have 3 PCs, 3 switches, 3 routers. They can ping each other as far as the router can ping this router can ping this router. They can only ping each other, and they can ping their respective PCs that they're connected to. So you're not able to get across. So PC7 here can't get to PC8, and PC8 can't get to PC9. So this is where we come in. Okay, this is where we come in. We need to go ahead and be able to route. Now, what we're going to do first is the following. All right, we'll take it step by step. We're going to ping a destination PC. So let's say the PC that's right here in the 192.168.2.0 network, I'm going to try and ping it. And we're going to see what we're going to get so we can understand what's going on. So let's full screen this. All right. Can you see that okay? Let me see if I can make this a little bit bigger. Keep it on the screen. There we go. I think you can see that better. All right. So I'm going to go to PC7. All right. Why is it coming up over here? All right. So we're in PC7 and we're going to ping. Let's bring it all the way here. We're going to try and ping PC8. So PC7 is going to ping PC8. We're going to try. So we're going to do ping, lowercase, ping 192.168.2.1. And let's see what we get. It says unreachable. It's unreachable. Let's take a look at our IP configuration. So we're going to do IP config. Oh, no, you can't do that here. Show IP. So we have a 192.168.1.1 and 1.254, right? So let's take a look at the router. Can we ping? Well, let's go back again. Can we ping our own gateway? Why did we get an unreachable? So the troubleshooting, ping 192.168.1.254. Can we get to it? So I can get to my gateway. So let's go to the router. So let's go to router. This is router 1. And let's take a look at the interfaces. Show, and we can put this in caps. Show IP int brief, right? Summary. And there's the 254. It's up. And then 10.115 is up. But what don't you see? This router has no clue about this network over here. Let me minimize this. So this router has no idea that this exists. So it can't get you there. It cannot get you there. You're getting a not a request timeout. You're getting an unreachable. You didn't pass this gateway. That's it. You're stopped right here. All right. So there's things that we can do, right? In routers such as like router 1 and router 3, which are edge routers. Let me get rid of this notification thing. And let me move it a little bit to the left here. So it does pop up. You can see it. Okay. So you can, what we're about to do, you can do it on this router, router 1, and on router 3. They're considered stub routers, edge routers. There's only one way in and one way out of the network. So we're going to configure something called a default route, which is a gateway of last resort. All right. And let's take a look at that as it's configured right now. So here we were just looking at a summary of the interfaces. If we look at the routing table, show IP route, right? So this router knows about the 10.1.4, and this router knows about the 192.168.1.0. It does not know about the 2.0. It does not know about the 3.0, and the gateway of last resort is not set. So that's exactly what we're going to do. by creating a default route, we're going to set the gateway of last resort. And what is the gateway of last resort? Let me get my face back in here. All right. The gateway of last resort is telling the router, hey, listen, I know you don't have an entry for these destination networks. You don't have it. So use the gateway of last resort that's going to send you to my neighbor router, and that router may know where to take you. That's what the gateway of last resort, so the router just doesn't drop the packet like it did and you got an unreachable. That's what a gateway of last resort is, or default routing, or a default route. That's what it does. So let's go ahead and do it. Okay. Let me, oh, wrong screen. There we go. Now you can see that. All right. So we're going to go ahead and keep clicking on the wrong screen. So we're going to go to global configuration. We are in privilege mode, even though your test is considered enable mode, which is ridiculous, but whatever. We're not going to get into that. Global configuration. And then we're going to say IP route, spell it correctly, 0.0.0.0. These first sets of zeros, you're matching whatever network it's coming your way. The next set of zeros is matching whatever mask is coming your way. And you're going to tell it to go to the next router's hop address, which is 10.1.1.6. All right, which is this router, right? This IP address that's on this interface right here. Now I can keep going, putting verbose, putting on a whole bunch of other stuff. We're not going to. Simply just this. All right, so we're going to do WR. And remember, look what it looks like right now. Gateway resort is not set. Hold on. Gateway resort is not set. And we only know what we're connected. Oh my God. We only know what we're connected to right here. Okay. The 1.0 and the 10.1.4. Okay. So let's take a look at the routing table again. Show IP route. Now we have an S with an asterisk. Asterisk somewhere in here means that that is a candidate default. Okay. And that S, where's the S? Somewhere up here probably, is a static. So this is a static candidate default route. If you want to be specific, it's a default route. That's what it is. And it's telling you where to go. And you can see it right here. Right? It's an administrative distance of 1. That's what this 1 means right there. Because you're using the next router's hop address. If you were to use the exit interface, it would have been 0, or it would have shown you as connected directly, or directly connected. But we're not. All right, so let's see, now that I did that, if I'm going to get an unreachable. All right, so I'm going to minimize this. I'm going to go back to PC7. And you can see we got unreachable before. Let's see what we get this time. It's up arrow, up arrow. And what do I get? Now it's taking a little bit. And now I'm getting a timeout. So what happened? It lost its way back. So what's going on is the packet went up to the router. The router didn't drop it. I don't see it in my routing table. Let me get my ball head back in here. Hold on. Okay. I don't have an entry for that destination network, but I do have a gateway of last resort. Let me use that to get across. So it went all the way across to that middle router, router number 2, right here. And then router number 2 says, hey, listen, man, I don't know where that's at. So I'm going to send back a timeout message. Oh, okay. Because he doesn't know either, right? That router has no clue where, well, it should. Now, well, who did I ping? 2? Hold on. I'm pinging 2. Oh, he does. Sorry. Router 1 doesn't know where 1 is. So literally, it did go here. Say, okay, oh, you want to go to the 2? Okay. But when it comes back up, it says, yeah, I don't know where you're at. I have no idea where you're at. Oh, okay. So how can we fix that? Well, let's create a static route on router 2 that points back to router 1. How about that? All right. So let's go, or points back to this network, 192.168.1.0. Let's do that. So I'm going to go to router 2. I'm going to bring it up here so you can see what I'm doing. All right. Now we're going to do a special kind of static route, which is called a floating static route. And I'll tell you why in a second. Let's just get it done first. Enable, config T. I'm going to say IP route. I want to go to the 192.168.1.0 network that has a subnet mask of 255.255.255.0. How do I get there? Through my neighbor to the left, 10.1.1.5. Now, we're not done. If I were just want to do a normal static route, that will be fine. You can hit enter at this point. But what happens? The administrative distance, let me get my face back in here. The administrative distance, whoops, not my whole body. You. No, the administrative distance is going to be 1. So when I want to do the dynamic routing, which we're going to do RIP, RIP will never take, it will never go into the routing table. It will never do anything. It will never make it there because the lower the administrative distance is king. So in this case, we're going to go ahead and put an administrative distance that's higher than RIP because RIP is 120. So let's go ahead and do that. And that is considered a static floating route. So let's go back in here and let's space and put 150. That is a static floating route. If I would have put that, would have been just a regular static route. And hit enter. That's all I'm going to do. I'm not going to add the other network. We're working on the left side right now. Do WR. So what should happen now is that when this PC7 is going to go up to router 1, excuse me, my throat is acting up, and then it says, hey, I don't have an entry for the 2.0 network. That's fine. I'm going to send it because I have a default route, meaning I'm going to send you to my neighbor. My neighbor is going to take you down. But now when this PC tries to reply, right, ICMP request reply, hey, I want to go back to 1.0. Now the router has a static entry to say, okay, I know where that's at. Let me send you here, and you should be able to ping at this point. So let's take a look. And now you're able to ping because now both routers know where to send you in order for you to get connectivity. So the same thing is going to happen on this side. Same result. So let's go ahead and configure it. Let's go to router 3 and create a default route, a gateway of last resort. IP route, match whatever network, match, whatever mask, and send it to my neighbor. And this is wrong up here. It's supposed to be 9. I'll change it now. 10.1.1.9. It should be 8, I should say. Sorry. All right. That's my default route. Okay. Pointing it to my neighbor. Let's take a look at the routing table. Do show. Oh, you can't see it, can you? Let me put it up a little bit higher. Clicking on the wrong screen again. So this is what I did. Right, because this is wrong right here. And then I'm going to do a do show IP route. Okay, and we have our S with our asterisk. Lovely. And let me change this right now so it doesn't cause any more confusion. This is 8. You have 9 and 10. Okay. So let's go back to router 3. And now, well, now router 3 already has the default route. Now I got to go back to router 2. Right? Let's take a look at its routing table. Do show IP route. So here you have a static entry with an administrative distance of 150 for the 1.0 network. Now we got to tell router 2, hey, there's another network, which is called the 3.0 network. Let's go ahead and put that in there with the same AD, 150. So we're going to do IP route 192.168.3.0. It has a mask of such, right? 24-bit mask. And you're going to send it to my neighbor, 10.1.1.10. 10.1.1.10. But we're going to put a 150 on there. So when I do rip, it'll take effect. All right. And let's verify that indeed that took effect right now. All right, let's Control Z, go to privilege mode, swipe here out. So now you have a static entry on router 2, not only for the 1 network, but you have one for the 2 network as well. Okay, you have 2 entries, and you can see here the static route is 150 as well. Okay, but you have 2 entries now to do that. So theoretically, now you can go to PC1 and you can ping all the way across. Now you should have connectivity to everybody. All right, so we were able to ping 2.1, that's up arrow. Let's ping 3.1, and we get a response. So that is what we call static routing. Now, it's fine for static routing is fine for small networks. Okay, yeah, you can do default routes. You don't have to create static routes, right, on those edge routers. And then on every router that has multiple ways out, you will create a static route. Static routes are also a good way to control your traffic, right? You have full control over it, and it doesn't burn your router or take up your bandwidth. But now you're getting complex. Now you're scaling, up on your network. So now we want a routing protocol. Now, obviously, RIP version 2, it's a maximum hop count of 15 routers that it goes through. So that's what it's considered for small networks, not too complex, but you're growing, right? Let's say you added 2, 3, 4 more routers. You don't want to put in static routes. It's too much of a burden on you. So in order to manage that yourself manually, you go ahead and create a dynamic routing protocol. Okay, and in this case, we're going to do RIP. So let's go ahead and do that. So we're going to go back to router 1 and make sure you can see. All right. So now keep in mind that RIP is a distance vector routing protocol, which means that RIP summarizes by default. So in this case, since we have a 10 network, RIP version 1, version 2, whoever uses version 1 now, I don't know. They need to come out of the Fred Flintstone era. But version 2, or RIP period, does not see that this is a class A address that has been subnetted. It doesn't see that portion. All it sees is a class A. So we need to do something called no auto summary. No auto summary. So let's take a look at that. So enable. We're in router 1. We'll say router RIP. And you don't need to do it in this order as long as obviously you got to do router RIP first, but then you don't have to do the version 2 right away, but you can. I do, because I tend to forget the version 2. And then the networks that you're attached to. Network, I'm going to show you something. You do not have to put the entire network there, but I'm going to. And then network. For this one, yes, because the class full boundary here is that 3rd octet. And hit enter. Now I'm going to show you something. Do show IP protocols. All right, so you can see RIP is running on here already, but look what it says. Automatic network summarization is in effect. When we type no auto summary, that disables that. So you see that this is on right here, right? So when I do no auto, I'm going to tab it, summary, and let me save that so I don't forget. That's going to go away now. Let it finish doing its thing. Do show IP protocols. Now, automatic summarization is not in effect. So now it sees in the updates, it will send out the subnet mask along with it. All right. So it knows that, hey, this is a class A that's subnetted, or else it would not work. But I do want to show you something real quick. If I do, let's just do a show start. Not to get too fancy. All right. There's something simple. There's your interfaces. Take a look what RIP did. Take a look. It's still, I put in there 10114. It will enter it like that. Don't worry. That's fine. Because your concern is when it sends it out, that it sends the mask with it. Okay? That it sends that mask with it. And again, the command, the show command that you can type is show IP protocols. All right. And you want the line that you're looking for is this. You want to make sure, especially in RIP, that is done, that is turned off. Cool. Let's go to router 2. So now you know. So yeah, we're good there. Conf T, router RIP, version 2. Oh, not Varion, version 2. And then network. I'm just going, since it's going to summarize it anyway, it's going to enter it that way, I'm just going to do this. And then the network beneath me, my LAN, cannot forget no auto summary. Do WR. All right, let's go to router 3. Router RIP, version 2. Network 10.0.0 and network 192.168.3.0. And what can't we forget? No auto summary. WR. So let's maximize the screen and let's see where we can ping. Let's ping 192.168.1.1 and get there. And we can get there. So now, what are we using? Are we using static routes? Here, if you do a show IP route on router 3, we still have our gateway of last resort. That's never going to go away. That's there, okay, just in case. But we're using RIP. We're using RIP to get to the 10.114. We're using RIP to get to the 1.0, and we're using RIP to get to the 2.0, and here's the administrative distance right there. But to be fair, we didn't do any static routes here. The static routes were done in router 2. This is router 2. Let's maximize that. Control Z. Let's take a look at our routing table. Show IP route. And there you can see there's no more S's. There's no more S's. Now we're using dynamic routing to get across. All right. And router 1 will show the same thing. We have a routing protocol, RIP, working. Now, if we do a show, let's do it in lowercase, we'll do a pipe command, show run, not that, show run pipe section static. Type it correctly, lads. Hey. Out. See that? All right. Let me bring it up. So here are the static routes that are configured in this router. This is the only one that has static routes. But because of that administrative distance, we said, hey, let's make it bigger than RIP. These are just there in case RIP goes haywire. It's going to go ahead and these will take over once again. All right. So that's the reason that when you're networking, let me get my face back in here. So when you network, especially in small networks, even in big networks, static routes are a part of your configuration, period, end of story. Okay. You need to do static routes for certain areas of your network. But for something as small as, no more than 15 routers, RIP is fine. It's not a big deal. You can use RIP. But if you're gonna scale, then you want to go maybe to EIGRP, but it says proprietary, then you probably go to OSPF and what have you. But RIP for small networks is just fine. But always you should create static floating routes. There's just backups in case RIP goes haywire. Boom, you got this static floating route that will always be there. If the dynamic routing protocol, somebody deletes it, whatever, you can still network. You can still get across to where you need to go. That is the routing process. That's how this works. Okay, so administrative distance is king. The lower is the more believable. All right. Default routes have nothing to do with the administrative distance. Okay. That's it. Very simple. Practice makes perfect. So make sure you practice this lab. And also remember to subscribe to the channel, ring the notification bell, and please leave comments. So give me feedback so I can see what you guys want to see next. See you next time.